All right, so we were discussing about this denormalization concept only, right? Basically, we are discussing about normal forms, and on the previous day we almost done with the 2NF, right? I hope you can able to see my screen.
Yes,
Okay.
third point was left, ma'am.
Yes, the last rule was left in this 2NF. Once we are done with that, let's see 3NF and let's finish this concept today. So yes, this is the sample data sample which I had, and from that I just took some rows only, and this is our normalized data, right? And this what I did, I just randomly took some rows of data and we call it as denormalized data. Okay, and from this we need to convert it into 1F, 1NF, 2NF, and 3NF, right? So what is 1NF says? Each column must have one single value and each row must be unique, and no need of giving any primary keys, correct? So with respect to that, what we did, first rule, we just, as you can see multiple values here, we just divided them or we just splitted them and we got like this, correct? Guys, am I uh, can do you feel any kind of disturbance? Hello?
Yes, ma'am. Audio is okay.
Okay, fine, thank you. So this is 1NF, and from this we on the previous day we discussed what is candidate key, and with respect to the candidate key definition, we took order number and product code as the candidate key here, right? In the 2NF we have this rules, like the first rule will be like the data must be in 1NF, right? So that is the reason the rule 1 is data must be in 1NF. I just copied the same data which we got in the 1NF. This will be that one. And the second rule is all non-key attributes that we have, that must be fully dependent on the candidate key, correct? So this order number and product code is our candidate key. Non-key attributes in the sense, as I said, the remaining columns which are not defined in the candidate key. I mean all the columns, if any column is not defined with any key, maybe primary key, foreign key, candidate key, if we didn't define any key on any column, we will call that basically as a non-key columns or non-key attributes, right? We saw this concept also on the previous day itself. So as according to that, as none of the keys, none of the another columns are fully depending on the candidate key, that is this data is depending only on the order number but not on the product code. This data is depending on the product code only but not on the order number. In the same way, we have another few more data that is also not fully depending on the candidate keys. So for that reason, here as per this rule 2, if they are not fully depending, in the sense we will call that it is as partially dependent. If that is so, we need to split them into separate tables. That is what I did in the previous class, right? So what I did basically, for the orders, I just kept all the orders details table in one table, and I gave the name as order details table, right? In the same way, I divided the tables into product details table, customer details table. Correct? Till here we finished on the previous day. Correct?
Yes, ma'am.
So here we need to solve this third rule. We are left over with this third rule, that is every table must have a primary key and it should be connected to other tables with a foreign key. Now basically for all the tables we need to create a primary key and foreign key, right? So for the order details table, now we should just leave this table. From here only our tables are there, right? Because this is the output which we got in rule 1, but after applying rule 2, now this is our output. Correct? So for order details table I had data like this. And for order number, if you remember, we have some duplicates like 10104. It is repeating, correct? So as we have duplicates and the data is varying, I cannot remove this. I cannot remove this row, and as we have duplicates, I cannot use order number as primary key, right? So for that reason, I just randomly added one more column in this table and I gave that column as order ID, and I just given the numbers in a sequential order, right? And now I can declare this order ID as primary key, correct? That is what I did. Up to here we saw on the previous day, correct? So now we have product details table. In the product details table also we need to give a primary key. If we observe in product code also we will have duplicate values, correct? But you can see here in the first row itself I am having the code, but all the details are same. That is, I'm just storing these details twice. Correct? So no need of storing the details twice, as we are storing it in a separate table. Correct? Here, though I have the common data, I have order number same, but the details are different. Like my sales quantity order is different here. Correct? Here it is 33. Here is 24. So I cannot remove this row. That's the reason, instead of removing the duplicate values here, I just added a order ID, another column as order ID. But here if you can observe, all the data is same. That is the completely, it is, we can consider it as a duplicate row. For that reason I will remove one row here. Correct? Am I clear?
Yes, ma'am. Clear.
Right, just here the data is repeating again and again, so I can observe some duplicate rows here. Wherever I can see the duplicate rows, I will just remove them. So already in the first row I have the same data, in the second row also I have the same data, so I can just directly remove this row. Correct? I removed it. And in the third, here also same, so I can remove any of that row. Correct? Now is it, now we got all the unique details here. So directly for product code only I can apply a primary key. Correct? Now all my data in this product details table is unique. So without adding any another column, I'll just declare this product code as primary key. Okay? Or else I'll write it here. Or else I'll write it here better. Okay, my product code will be my primary key in product details table. In the same way, I have customer details table. You can see here also the just the data will be repeating. Here customer names, in the sense in this particular set data set, it is not an individual customers. It is something like an some what we call some stores like that. Okay, it, so you can see Euro shopping channel, we will have the same details in the complete row. So basically I will remove this also, right? In the same way, here this is also the same. Correct? I can remove. And I think that's it. Nothing is repeating. Correct? Here nothing is repeating, but we won't consider customer name as primary key because names may vary. Correct? So here also, if we see another columns also, we cannot take this columns. Instead of considering this columns as primary key, I will just simply add another column here, maybe as customer ID, right? and I will give random IDs here. Okay, and I will consider this as my primary key. We can do like this. Okay, in this way, if we are doing like this only, we will get all the tables, yeah, all the kind of these tables, and for that tables only we will create primary keys and foreign keys. Okay, just to get that kind of uniqueness, to satisfy the rules, we will divide like this. If needed, we will add some columns. Okay, at the end of the day, whenever previously as we worked in Maven movies, we saw many tables. All the tables we saw like this only, right? We have all the details related to one table in one particular table. We will have some IDs, and for that IDs only we will mention primary keys, correct? That is what we will do here basically. Okay, this is customer details table. So basically, of all my tables, my primary key is created, correct? Sorry, I need to keep this. Okay, so right now primary keys is done. Now we need to create foreign keys as per the rule 3, correct? We need to, every table must have a primary key and it should be connected to the other tables with the foreign key. That means for each and every table what we have, we need to connect the foreign key here. Okay, so again, see, whenever we create foreign keys, there are two methods. In two ways we can create the foreign keys. Okay, first method is that, if you remember, we already discussed whenever we are discussing about the limitations of Excel, right? If you remember, we had some order details table there. We if I'm not sure where it is, where I mean where I saved that Excel file. I'm not opening it, but I hope you remembered that, right? Do you want me to open that file, and do you want me to show once again, or did you remember? We saw, whenever in the initially, whenever we are discussing about the limitations of Excel, we saw some kind of data, where in that data we had some, order ID, customer details, product details, right? First we took one table as the base table. Just a minute, let me open that file.
No issues,
So
Divi.
yeah, I got it. So this is the file, right? This is the thing which we saw whenever we are discussing with the limitations of Excel. Like this, we had the data, and what we did there, we divided the data into different tables, if you remember, right? Maybe customer details table, order details table, like that. But here, what we did, we took this as a base table. We considered this as a base table, and as we considered this as a base table, we kept all the primary key columns here, like customer ID, product ID, supplier ID, and order ID. We kept in one table, and we thought this as a base table. At the bottom, we created some tables, and we make sure that we have the common columns between this individual tables and the base tables, right? Like in customer details table, I had customer ID. In the base table also, I had customer ID. Like that, I said we will create like that. This will be the common columns. So by using like this, we will create a foreign key, correct? Now this basically, this in the customer details table, my customer ID will be the primary key, and from the base table, this customer ID will be the foreign key. And the same goes with the all the tables. In product details table, product ID will be the primary key, and from the base table product id will be the foreign key. Like that we will relate. So whenever we create the foreign key, there are two methods. Either we can use one base table, and we need to make sure to use all the common columns in this table, so that in the base table only, for all the common columns we will declare them as the foreign key. Okay, am I clear?
Yes, ma'am.
So the second method is that, instead of considering this as instead of taking the base table, what we will do directly, I won't consider here the base table. I will, in this is my order details table, this is my product details table. I don't have any base table here, I just have separate three tables here, correct? So another way is that, instead of choosing, or instead of taking any base tables directly, what we will do, we will create a separate table called as relations. Okay, we will create a separate table called as relations. In every time we can do this, either we need to choose one base table, or else we need to take another table called as relations, and in that table we need to store all the common columns. This table name will be relations. Okay, the table name will be relations, and here inside this table name, what columns I will keep, in the sense, from this order details table, order id is my primary key, correct? I will just copy this, and inside this relations table, inside this relations table I will keep order id. Okay, in the same way, this is the table name. Okay, this will be the column names or order id. In the same way, I will take this product code. Okay, whatever columns we are considering as primary key, that all columns we will store here. Just give me a second.
Hello, Divya. This is what the engineers will do daily.
Yes, data engineers, this is what they will do mostly.
Complicated on this.
Yeah, that is, it's full of headache and full of logical thinking. We need to understand which column we need to take as a candidate key.
Yes.
Everything is really,
Yes.
yeah. Maybe the concepts are different, but that the work we need to do a lot. We need to continue the amount of work we will do in the as the part of data analyst and data engineer. Data engineer will be a little bit harder, or instead of smart work, hard work will be there, I guess,
Yes.
in my
Yes.
perspective.
Um,
So like this
Divya, one more question.
yes, please.
Who regarding about the salaries, who are paid more, data engineers or data analysts?
I really cannot say any statement regarding that. It again depends on the experience you have, and it depends on the in data engineers there will be many tools. How many tools depending upon that the salary will be decided. It's not about, if you want to become a data engineer, you can start by learning only three or four subjects, but eventually that is something like an ocean. There will be it won't end. We need to learn some 12 to 15 subjects over there. So as much as subjects or as much as tools, that much of demand you will have, and according to that it depends our salary. Data analyst is not like that. Here also, of course, if we are good with ETL tools and all, but we will have that range only. Okay, for the data analyst, at the starting range also will be the high, and according to our experience the salary will increase like that. But data engineer is not like that. As I said, it will also starting salary also will get good package only. But as I said, we need to learn Hadoop over there, we need to learn about big data. So many things are involved in it. If you really capable to do all the things, then you will have good package, very good package. You will get a more package than data analyst.
We
But
will
we
be covering BCNF concept also, Divya, in this main course after
uh,
3NF.
no,
Oh,
we are
no.
not covering, we are not using BCNF nowadays.
Okay.
Okay.
Okay. Then.
So
Okay.
okay, all right. So yeah, this is how we will just store all the primary key columns in one table, and we will just name this table as the relations. And whenever we are using this see, whenever we are creating the foreign key syntax, we saw we will write like, after writing the column name, we will write references, and we will tell, right? In the same way, when in the relations table, whenever we are creating the order id, we will say order id references order id of order details table. Like that, we will use the references, we will keyword, and whatever, however we will write foreign key syntax, that syntax only we will write. But basically we will create a separate table for this. Like this also we can do, any method is fine. Or else you can even consider this base table, and you can you can include all the primary keys in that table, as how we saw previously in that limitations example. Like that also we can create this is like this also we can create, or directly we can create a separate table, and we can store all the only the primary keys we need to store in a separate table. And we will definitely, by default, we will call this table as relations only, relations or relationships. Okay. So by creating like this, I will full now our last rule is also satisfied. Here only all these columns will act as a foreign key. Okay. But basically this foreign keys we will take reference from this tables, right? That is the reason we will consider that for each and every table we got foreign keys. Okay. The creation is a little bit different here, as we are storing all the keys in a separate table. But this is how it is. Am I clear? So we are done with third rule also. Actually, to be frank, I can really tell 99% no one will include this concept in SQL classes. If you attend edtech companies also, they will tell, if they will tell the normal forms, they will just explain you the definitions, and they will explain you what is partial dependency, what is candidate key. The definitions they will give, but no one will explain along with the examples. 99% I'm very sure. Here I'm just explaining you just for your understanding purpose. Just try to understand how much you can understand, that much only. Okay, no need of taking any stress. Consider this is as an extra topic only. Okay. Because being SQL developers, we won't work on this mostly, but we should have idea that what is going in the back end, how it is, basically how the data is coming, like, how the denormalized data, how normal, very raw data is converting into the normalized form, so that we will work on the normalized data only, right? So to get that idea, I'm explaining this. Okay. If anyone, if you have any doubts, you can ask me still. If anyone is, if anyone is feeling difficult, don't, no worries. Okay, you can just leave this topic also. Try to understand how much you can. So I hope this 2NF is clear for everyone. And because the last rule is also satisfied, we created primary key and we created foreign keys.
Yes, ma'am. Clear.
One
Great.
more is there now.
Three enough. It is not at all finishing only. But some I will. This 3NF is simple only. I think we will finish it today.
Okay.
Frankly, in every batch also I won't cover this. For some batches, if I really feel, if I feel that at least some students, or 80% of the students are interested in listening and they can understand, for that batches only I will include this along with the example I will explain. Or else I will also explain only with the definitions, and I will try to explain orally only, not practically. Frankly, I'm being frank and I'm telling frank.
Divya, do you have any knowledge about developing course, Divya?
Developing courses in the sense which subjects?
Java, JavaScript, Dart, and Flutter, like that.
JavaScript, I know, not and any other things. Previously I had a knowledge on web development, but
Okay.
I am not working on it. I mean, after completing of my BTech, I developed one application in Samsung Tizen OS.
Okay.
We have Samsung, right? Something like how we have Android phones. For Samsung, they had Tizen at that time. So I created one application for them, and that was completely based on the web development projects. I mean, web development concepts. So I had that much knowledge only. I didn't went into that domain. Later I chose this data analytics domain. So I was completely into this.
Okay.
Yeah. So yeah, this is about 2NF. Now let's see about
I have
3NF.
one question.
Yes,
Okay.
please, Sweta.
Yeah, while you were explaining about the initial days of MySQL installation, everything like that.
Yes.
Okay. And after we like uploaded the Netflix data, is there anything like limitation, governing limitation, something like that? So how much data it can hold
No, it's
once
not. It's
we
nothing. It's nothing like that. We can that it can hold how much data it can, but it can hold the data. But whenever we are, I will show that afterwards in MySQL. We
Hmm?
can limit the display of the rows. There is one option over there. If we choose
Okay.
according to that, it will show the if my database in any one my table, if it has 3000 rows, I can restrict it to show only up to 1000, 2000, like that. The output of however it is displaying the rows, that one we can limit just for the display purpose. But database, it can hold the data. It generally won't have much limitations for holding or memory kind of thing. We don't have that issues.
Like I'm asking about after writing the query, like how much, I mean, how many rows and columns it will be displaying, that limits. You're
Yeah,
also telling the same, right?
yeah, I'm also telling the same. If that is your question, we
Hmm.
can have that option where we can limit to display the records. Not
Okay.
today, Sweta. I'll definitely show you tomorrow. Okay.
Okay. Okay.
Okay.
And we will be also covering the two questions, Divya. I'll ask you very quickly. One
Yes,
is
please.
like when I was like Googling, I was just saw a I mean a word called upsert, UPSERT, update plus insert. There is a command called upsert.
Okay.
Okay, please let me know about that. Okay, and one more thing is we will be covering anything like rank
Yes, we will
concept here.
cover. That is actually Windows functions are there. It was not
Okay,
included in the what we
the
call in
content.
the content, but definitely that is actually important concept. I had to include in the content, but still, if it is not in the content also, I will definitely cover Windows function in the course. If not in the course, in the interview questions, I mean, at the last 1 day or 2 days, we'll discuss about the interview questions and doubts, right? Doubt sessions.
Okay.
In that
Mm.
interview questions, I had that Windows concepts questions over there, because if you are trying with an experience into SQL developer, that is a definitely important interview question about the window rank function, dense rank function. We will cover that, no problem.
Okay, okay, Divya. Thank you.
Okay.
Divya, can you know me about MySQL certifications types?
Okay.
So what type of certifications need for 3 or 4 years of experience?
And only MySQL or data
Uh,
analytics kind of thing?
Only MySQL. Like,
Only.
yeah, it will be used for the developer role as well as data analyst role.
Okay. Okay. I'll let you know. Okay, about that also. Because for complete data analytics and data science, I know certifications, but only for MySQL, even I need to search. Frankly,
Mm. So I
only
think
for
it will,
MySQL, I don't know.
yeah, it
Yeah.
will use for a, so if you want to go to developer side, so that time it will use, right?
Yes. Yes. I got your question. So basically, if you really want to become a developer side of thing on, or if you are thinking only about MySQL, mostly companies will see for the hacker rank certifications we have, right? We have one website called as hacker rank. There you will get so many examples to even practice purpose also, and they will provide some we can write tests over there and they will provide certificate. It's not like a complete certification course, but we can download that certificates and we can include them in the resume. That will add a lot of weightage for our resumes. Hacker rank is I will show you later, okay, about that.
Okay.
So actually maybe I forgot to say, or we didn't got this discussion right, everyone. Most of you already might know about hacker rank. If not, please search, there is a website called as hacker rank. There, from the initial topics of SQL, you can practice a lot. We have many examples over there, even topic wise examples also you can solve. You will have they will have a lot of questions. You can even write exams over there like that. Just go through that website once, okay.
Yeah, at the end of the session, can you show us once
Sure,
where to
sure,
open and where to
I'll do that.
practice it?
Yes,
I'll do that.
I had already gone through that hacker rank.
Yes,
Yes.
hacker rank. It is actually most of the people might know about it. But that is very important. It helps us to learn, along with the examples. And if we at the end, after writing exam, they will provide a certificate. That certificate also, all the certifications, how much you can do that, please, complete them and add them in your first LinkedIn. Everyone, I hope every one of you have your LinkedIn accounts. If not, create your own LinkedIn accounts and try to upload all the certificates over there, and add your certificates in your resume also. I'll show about that website going forward. For now, please don't mind, let me complete 3 enough, okay. I really don't want to continue this topic tomorrow. I'll just finish it off quickly and I will show whatever doubts you have. Let's discuss after this concept or tomorrow also, and I will show you the hacker rank also, okay. I hope it's okay for you.
Yes,
Okay,
Divya.
Divya.
Okay, thank you. Because almost from 3 days we are discussing on the same topic, and it is really. So let's see about 3NF. In 3NF we have basically two rules, okay. First rule is that data must be in 2NF. As usual, on this data only we need to perform 3NF. This is a common rule for every normal form, right? So the second rule is that there must no transitive dependency. There must be no transitive dependency. Basically, we have one concept, one term called as transitive dependency. That means, if you can see here, I wrote it clearly. If I say A depends on B, suppose we have A, B, and C. Okay. If A is depending on the C and B is depending on the C, then indirectly I can say A will depend on the C, right? Or else I will take one example and I will say, but basically there, wait, just wait, let me tell with example only. See, let me open our denormalized data once again. Okay, in this I will try to explain you with this example. Okay, so now we have a thing called as transitive dependency. What is that means? Suppose here in this denormalized data, we have customer name, right? So we have customer name. Let me, just suppose I am taking this customer name, I'm considering this customer name as A. Okay, suppose this is my customer A column. I am just imagining this customer name as A. Okay. Next, we have a column called as maybe order number. We have order number column. We have order number column, and I will consider this column as B. Okay. So customer name as A, order number as B, and next we have delivery person first name. Okay, let me take this as C. Okay, So now in this complete table in the denormalized data, we have many columns, but let me just consider this customer name as A, order number as B, and delivery person name as C. Okay. So I'm saying that if A depends on B, B depends on C, we can say A is also depending on C. That means customer name is A. Okay. Suppose here I'm considering A as my customer name. I'm considering order number as B. That is, if I know my customer name, along with the customer name, I can understand order number. Right? If I have customer name, I have order numbers, right? If I have customer name, see, this is basically my orders details table. I know customer name. I wanted to find the order number. I can find with the help of A, I can understand what is order number, right? And if I know the order number, am I right? Is this right? This is my order details table. I'm only purchasing all these orders. I have 8 orders. I wanted to know what is the order number of one customer name. I can know, right? With the help of the customer name, I can see what is the order number by from this table, correct? If I know customer name, I can understand what is our order number, right? That is, I will say A is depending on B. Okay. And next we will see if we have any of the order number, and if I want to know who is the delivery person for that order, still I can get my answer, right? That is, if I know B, I can get C. Correct? I have an order number. I want to know who is that delivery person. I can know. Correct?
Yes, ma'am. Correct. In mathematics, also, and this rule is called as
This
transitive rule.
transitive dependency. Yeah, you got my point. So in the same way, if we know as how we are by with the help of A, how we are able to understand B, and with the help of B, if we can able to understand C, that is delivery person, I can say directly with the help of customer name also, it we will understand a delivery person. See, if I know customer name, I can understand who is the delivery person for that particular customer, right? This is basically this concept is called as transitive dependency. Okay. I hope you understood at least something.
Yes, ma'am.
So basically we have this concept as someone said, I didn't saw then who said that, but as someone said, in maths also we have this. If we know this, with the help of this we can understand this one, and with the help of this we can understand this one, then directly I can say, if by from A, if I can understand B, from B I can understand C, directly we can relate with A and B, something like, I can cancel B and next I will get A and C, right? In maths we will do like that. Here we need to understand the concept like this. Okay. So from if I know customer name, I can understand my who is the delivery person for that particular customer, based on that order date. Okay. Like that it is. This concept is called as basically transitive dependency. Okay. In 3NF now, in 3NF they are saying that we should not have transitive dependency in our data. Okay. That means in one table, we should not have A, B, and C. At least two also we should not have. I should not have A and B together. I should not have A and C together like that. A, B, and C should be saved separately, should be saved in different tables. We should not include this, whatever columns we are using to understand the transitive dependency, that columns we should not store in one table. That is the rule here. Okay. So there should not be transitive dependency. If there is a transitive dependency, we need to split the columns. Let me write it here. Again, the same concept as how we saw in 2NF. If there is no fully dependency, we will split them into separate tables, right? In the same way, there should not be transitive dependency. If any column is existing which shows transitive dependency, we need to split that also into separate table. Okay, basically this is the rule. I hope, I don't know how many of you got my point, but try to understand. Okay, no, I really cannot give not more than this example. I hope you got my point. Is that okay?
Yes, ma'am. Okay.
Okay,
If you
thank you.
do, revisions will come to know exactly.
Yeah. So let's see if we, after splitting the columns, you can understand. So here, this is the 2NF. As I cannot really copy everything here and I cannot perform, I'm not copying here, but basically first rule is the data must be in 2NF, right? So on this data only I need to perform 3NF, correct? I'm directly copying. After satisfying 2NF, what will be the data? I'm just copying that one. So if you observe, let's observe from here only. Okay, so this data is in 2NF now, and I'm saying the 3NF that there should not be any transitive dependency. If we have any columns is showing the transitive dependency, we need to split them into separate tables, right? So here I said my order number, customer name, this is the thing, not that from here. Okay, so I said my order number, customer name, and delivery person name is showing is we can consider these three columns into transitive dependency. So we should not keep all these columns together. That means I have order number in already in a separate table, customer name already in separate table, but now I need to remove this delivery person names from here, or else it will it won't satisfy this rule. We should not maintain transitive dependency over there. Basically, frankly speaking, any of the data engineer don't really try to understand what is transitive dependency over there. By default, with some experience, we can understand. We can simply, by seeing the data, we can divide. Basically what we are doing in the previously also, this much of data we have, this many columns we have. But if you try to see the data, end of the day we will divide all the related data into one tables, like all the order details in one table, product details one table, customer details one table. Like that directly we will work on. Okay, with some experience, we can understand for every kind of data in every domain. After if we get some experience in that domain related data, we can directly decide without checking all these rules also. Like with some experience we can get that. So here, as delivery person is having in the order details table, now I need to remove the delivery person details also from here. Okay, that means I will remove this two. I'm just copying here, I'm not removing, because this is 2NF, right? So better what I will do, I will copy this one. Okay, here I'm writing 3NF output. So this will be our order details table. Okay, order details table in one. This is one order details table. Okay, now in order details table we have three more columns: delivery person name, delivery first name, last name. Basically this delivery person details only we are considering into the transitive dependency, right? So deal size we can keep as it is in the order details table only. Okay, I'm just keeping here because I'm going to remove that tables, this columns, right? I will keep that columns at the end. Now this will be my second table. This is our first table, that is order details. This is our second table, product details. And this is our third details, customer table, third table, customer details. And definitely we need to keep this relation stable also. And now what I need to do, I need to create another table only for this delivery person. So I will say I will create a separate table for delivery person, and I can keep any name, maybe delivery agents details, something like that. Okay. Now we need to follow, now to satisfy the third rule, I just divided, you know, the transitive dependency columns, that is customer, I mean, sorry, delivery person details, into a separate column. But again, here after dividing also, we need to make sure to follow the 2NF rule. In 2NF, we have one rule that for every table, we need to have a primary key, and that should be related with the foreign key, right? So to satisfy that, now I need to mention one, primary key here. For that reason, I will create another column here. Okay. Another column, maybe employee ID. Okay. Because delivery persons in the sense employees only, right? So maybe employee ID, and I will give randomly employee IDs here. And we can consider this as primary key, correct? And we will copy this same, and we will add in this relations also. We need to consider this as a foreign key. Okay. Like that it will be. Now if we do like this, it is satisfying each and every rule of 3NF. If you really observe, now we are done with 3 normalization forms. At the end, however, we will deal with all the, in the databases we will have tables like this only, right? This will be order details, product details, customer details, delivery details. By default, being a developer, we will get this data directly. But before getting the data to us, data engineers will do lots of they follow these rules to, convert this kind of data into this, that is denormalized form, to the 3NF. But as I said in the starting class, we have many forms, like going forward we have 4NF, 5NF also, but that is not needed. Up to 3NF, if we can know this is the data which now current, in the current situation, this is the data how all the companies are using. Okay. So right, Maven movies also, if you can relate, we have like this only. We have all the tables separately, and for every table we will have the primary key, like that, right? So this is about normal forms. I am done. So is that okay? Any doubts? Basically the output now what we got is satisfying the 3NF rule. So after performing 1NF, 2NF, and 3NF, now we got this data. We can call this data as normalized data, normalization. Okay. So I hope it is satisfying with the definition which I said at the first class. Let me.
And ma'am, whatever we get in the denormalized data, and then to access from data from this normalized, then all the normalization rules will be applicable, join and all that.
Sorry, please repeat your question.
Ma'am, whatever we got as output in a 3NF,
Yes.
and then we need to access data from 3NF, then we will use normalized rules.
Normalized rules in the sense, see, we already divided the data, then only we will get the 3NF, right?
Yes, ma'am.
So that is converted, that basically that output of, suppose this is I solve these examples on sales data, right? Whatever output I got, I can able to see this one only in all of my sales database, irrespective of the company, irrespective of the products they sell. In all of the sales database we will have this kind of tables only. The data will be differ, but only these tables I can see. So
Okay.
like that, basically we won't divide, or won't do like this directly. How I given you Maven Movies database, my company will give me sales database. There I will find all these tables. So before I receive this sales database, data engineers will do everything, whatever we did this normal forms, they will perform everything and they will give. Once we receive data, if once we started working on the Maven Movies, we didn't check, even we didn't know about the normal forms, we didn't check whether it is satisfying or not. We don't bother about it, right? Because it is already set. So I hope, is that the same question you asked me?
Yes, ma'am. Got it.
Yeah, thank you. So at the starting I said, in the normalization definition, if the data is divided into smaller chunk of pieces so that we can handle the data easily, right? Denormalization in the sense, I said, if we store all the related data in one single table, it is called as denormalized data. That is what we saw in the first, whenever we are solving the example. Later I said normalization in the sense, if that denormalized data is divided into smaller chunks of pieces, we can able to handle that data easily, right? And if we divide one large table into smaller different tables, we need to make sure that there should be common columns between them. So this is the definition of, or this is the thing about the normalization. I hope after solving this example, you know we just justified to this definition, right? We divided the complete large table into smaller tables, so that by using that tables only we will handle the data easily, and in every table we will have some common columns between them, right? So with this we are done with denormalization and normalization concept. Okay, but as I said,
What
don't
about
worry much.
yeah, what about entity relationships like one-to-one
Yeah, ER
linking?
diagrams I will show actually.
In
ER
reverse engineering,
diagrams,
like
yeah, in reverse
can you
engineering we need
quickly
to,
show here?
correct. Is I think we are done with the time, right?
Yeah.
Next class
Okay.
I will show.
Tomorrow we will start
Yeah,
with
and
this.
tomorrow, yeah. First I also thought to finish only denormalization. Next we have ER diagrams, but in, as you said, in reverse engineering only we can able to, I'll show the process how we will see the ER diagrams tomorrow, and I will explain a little bit, I mean, about what is ER diagrams and all, how we will check that ER diagrams. And after that we will start maybe a new concept, that is subqueries. Okay.
Yeah, in reverse engineering, you say enough the way we will understand easily.
Yeah,
It,
that
it will
is
take roughly
very
10
great.
minutes.
Correct. That is what basically whenever we are working, once we get any data, basically I will show on Maven Movies database only. So like that, whenever we are joined in any project, we can able to see that from reverse engineering, we need to know how to open the ER diagrams, then we can relate everything, correct? So that
Yeah,
is, I will,
I know how to open, but
yeah, for
I can
everyone, that
understand.
is what, I'll that is what I'll show you tomorrow.
Right.
Yeah. I already thought, because I thought today won't time won't sufficient for the ER diagrams, and that the steps is also easy only, or else we can see also, no problem. See, we have ER diagrams, right? To see the ER diagrams, what we need to do in this MySQL, we have a database here, right? Correct. We have a menu bar here. In this we have database. Inside the database we will have something called as reverse engineer. If we click on it, it will we can able to, can you able to see my screen? Yeah,
Yes,
okay.
Devi.
Yes. So if I click on reverse engineer, we will get into this page. Here basically all our details, like we will have some TCP folders kind of thing in real time also, and the remaining host name, port, usernames, every details will be there. No need of making any changes in it. Directly we need to click on next. Here click on next again. Again I will show you this tomorrow also, but for now I'm just showing you. Okay, now after doing that, we will get to see the list of databases we already created in our MySQL, right? So suppose if I want to see about the ER diagram of Maven movies, I'll select from here on what database I wanted to see. I will select that and I'll click on next. Okay, next again. It will show me all these things. For now, let me just remove them. We have tables, views, triggers here. Let me just remove all these concepts. Let's see about only the tables. I just check this box, and if I click on execute, I need to click on next once again, finish. It will show us the ER diagrams of Maven movies, what all tables we have, how they are related. We have primary keys, foreign keys, everything, right? It will show everything here. Whenever we join in any new project, first we need to check this ER diagrams. Here, by from here we can understand how many tables are there, how many columns are there. See, this is the primary key. We will have this symbol, the key symbol. The red color symbol indicates foreign key. Like that we will have everything. We will see tomorrow also a little bit. We will learn about this, and we will start subqueries concept tomorrow, and maybe tomorrow only I will show you hacker rank also. Okay.
Yeah, Devi.
All right. And about denormalization and normalization concept, just try to understand how much you can. Okay. Just don't worry about that concept. Okay. That is not that important. Just for understanding purpose, I said. Okay. Let's meet in tomorrow's class. Yeah. Bye bye.